Hello, and welcome back to the UAS Magazine podcast. I'm your host, Danielle Piekarski. Today we are joined by Ashish Kapoor, CEO and co founder of Scaled Foundations, who recently spoke at the UAS Summit and Expo in Grand Forks. At the summit, Ashish informed me of a blog he wrote, which we will be discussing today. Welcome to the podcast, Ashish.
Yeah, I'm looking forward. Thank you for having me here, Daniel.
Of course. Thank you for joining us. Let's start with having you tell us about Scaled Foundations and what you do at the company.
Yeah, so Scale Foundations is providing robot intelligence as a service. So, specifically, the biggest bottleneck to adoption of robotics, flying, walking, moving on the wheels, otherwise, the biggest bottleneck indeed is the AI software. We can go and buy all these fancy form factors, all these hardwares, but we do not have a good coherence story on what kind of software we can run on it so that these robots can be useful for us. And what Scale Foundations does is provide that missing piece. If you have a robot, if you have a use case that uses robots, of course, flying robots, because we are on this UAS podcast, you can come to Scale Foundations and you can get the artificial intelligence that you need to go and accomplish all the use cases and do your missions.
Great. Thank you. So, as I mentioned earlier, you recently published a blog which was titled 7 Lessons from AirSim. Can you explain some of your previous experience and what prompted you to write that piece?
Yes, absolutely. So prior to Scale Foundations, I was running Microsoft's autonomous systems and robotics research team for almost a decade. This is the effort that I had founded within Microsoft around 2014 when I was seeing what was happening in the field of deep machine learning. 2014 is still those years where it was not widespread, adoption of deep machine learning. People in computer vision and AI communities were still trying to convince other folks that this is the technology of future. And of course, I was saying that this was a revolutionary technology, and it was definitely what I call a non-differentiable jump in the capability of AI systems. So at that moment, I decided to spawn a research effort around aerial robotics and deep machine learning. And for the next 10 years, we did a bunch of stuff, including some of the work on AirSim. Like a lot of your audience might be familiar with aerial robotics simulator called AirSim, whose whole sole purpose was to accelerate development of AI software that would go on to flying robots. So, I've been doing that for last 10 years. Very widespread adoption. A lot of folks were, using it and still use it. So, yeah, so that's what I was doing.
Very cool. All right. So, as you mentioned, AirSim was released in 2014 and it's played a very pivotal role in advancing robotics research since. Can you elaborate on how its open source nature impacts the development of deep learning models for robots?
Yeah, absolutely. So just a quick correction. So the effort was seeded in 2014, but AirSim was fully first open source in 2017 February, right? So while the research group has been there for a decade, the first fruits of that labor you started seeing in 2017, and AirSim was at that time released, and it was open sourced. Machine learning and AI as a field have gained tremendously from being open, from the ability of folks, to build upon each other's work. And this is something, while it has been there in robotics, it's not still not that prevalent. We still see these companies who'll go and build their products in silos. They might take some dependencies, but this culture of building upon each other's work is a little bit limited in robotics. But with AirSim, it was very, very clear that if you were going to use the latest and greatest AI models, you have to work in an open arena. So, that was one of the primary reasons that we open sourced AirSim. And it has paid off handsomely. Over the course of 7 or so years, AirSim binaries have been downloaded about 650,000 times. And this kind of gives you a sense of how widely adopted the AirSim effort has been. I have seen folks who have done tremendous work with AirSim, either in wildlife conservation or in space robotics or in inspection. You can think of any application and you can see footprints of AirSim over there. So having an open system around AirSim, I do believe has greatly, accelerated some of the development of AI technologies that's going on to aerial robots these days.
Absolutely. So, moving on to the very first lesson, you highlight the need for a PyTorch moment for robotics before a ChatGPT moment. What are the biggest challenges in creating a unifying development framework for robotics, similar to what PyTorch has done for machine learning?
Yeah, and so, this is a question that I've pondered for many, many months now. There is a palpable excitement in the robotics world towards thinking about the singular foundation model, or what I call the chat GPT equivalent for robotics. I do sincerely believe that, we are a little bit, putting what I say, a carriage before the horse cart, in the sense that we first need to solve for the PyTorch equivalent for robotics. So I'll give you some statistics. The in the machine learning area, one of the largest and most influential conferences in Europe. There are 20,000 attendees. And compared to that, a top academic conference on robotics, especially robotics AI, is Coral, so Conference on Robot Learning, approximately 1,000 attendees. So if you use those numbers, so 20,000 for NeurIPS and 1,000 for Coral, it kind of gives you a proximate, ratio of between machine learning folks and people who are doing machine learning for robots. So as in, I do believe that for every 20 machine learning and AI engineers, there is probably only one or even less engineer who can actually work on real robots. So there is definitely a scarcity of talent. The second issue that I have in robotics is that we do not have enough data. Unlike in other fields of machine learning, like text or images, people can go and they can go on the internet and scrape all that data, but we do not have that luxury in robotics. So if you take those two facts, the fact that there are way fewer people who can work on robots, and multiply by the fact that we have far less data, I do believe that the chat GPT moment for robotics is still elusive. We first need to go and build those software platforms and scaffolding so that we can first, build upon each other's work. And secondly, start collecting data at scale so that this chat GPT moment for robotics can be enabled. So PyTorch for robotics is a little bit challenging. And a couple of challenges is that robotics in itself is a very fragmented field. So for instance, folks who do on aerial robots will work for aerial robots, during their lifetime. Same thing, when people are working on, say, manipulation robots, they will work on those robots for a lifetime, likely never talking to aerial robotic folks. But in essence, the AI that they are going to use is of the same nature. It's a neural network. It's a neural network that will go on an arm or on an airplane or on a vehicle. So consequently, we need to bring all of these communities together, unified by the AI architecture, so that we can share and build together.
Okay, very interesting. So, cloud connectivity and data management are becoming increasingly important in robotics. How do you see the shift from edge computing to cloud based services transforming the way that robots handle more complex tasks and multi-model inference?
Yeah, and I think, this is one of those topics that I often get pushback on, specifically from the drone folks or UAS folks who are actually flying these robots out in the wilderness and there might be no internet connectivity. But there are, a couple of things that I'd like to point out. I certainly believe that robots on the, with the cloud connectivity is the future, and there are, various good technical reasons. But on the pragmatic front, one of the most important consideration is data. So unless you have rich pipelines where you can accumulate data on the cloud, we are never going to be able to create a land AI into robots at scale. So example I give everyone is, for instance, consider your cars on the road, so specifically Teslas. The reason that they can make fast progress on AI is because they have all this infrastructure that enables them to mine all this data. Compare that to some of the government agencies, for instance, we are working on, and they are flying these robots at scale using manned pilots, teleoperated. But these pilots will not upload these data to the cloud. Even the friction of taking an SD card out of a drone and then putting that on a computer to upload is too much of a hassle. So unless we solve this cloud pipe connectivity, it's going to be very hard to for us to collect this data. The second point that I want to emphasize is the fact that a true autonomous or AI solution will likely have multiple neural networks running on a robot. Right now we are trying to fit one neural network on an edge device. Good luck trying to fit and run 10 or 15 of these models. And a drone that's always connected, that has the ability to spool off possibly 30, 40, maybe even hundreds of AI models, will have a giant leg up against a drone that is doing everything on the edge. So we need to start factoring into account some of these aspects as we design our modern aerial systems.
Of course. Okay. So, as with pretty much everything, but especially robot AI, safety remains a critical concern. What are some of the inadequacies of current approaches to robot safety? And how can tools like AirSim contribute to developing safer AI for physical systems?
Yeah, that's a great question, and this is one of the most important ones. As it stands, our AI models, or in general, the AI technology is, is almost non-deterministic. As in, it's very hard to predict when will they be correct, when will be they wrong, and so forth. And of course, with as you pump more and more data, you start to see performance improvements, but still you will get some of the surprises that you never anticipated. And safety is a critical aspect that's not been well addressed. you know like technologically, I speak with many of these researchers at the forefront, and they have been trying various algorithmic methodologies to address safety in AI. Tools like simulation here become very, very important. So tools like AirSim, for instance, it is a place where anyone can run their AI models and methodology and algorithms, and at scale try to figure out, the profile of failure cases. You'll at least try to get an understanding of when they might fail, when they might succeed. So at least you have an idea. You are not just, completely taken by surprise. The second thing that you could do with technologies, simulation technologies, is before you go and run your mission with these AI models, you should actually run them in simulation every single time before every single flight, and that would allow you to at least get a sense of what's the reliability of these methods that are going to be deployed on the real drone. And of course, AirSim and all these simulation technologies being open allows you to communicate with other folks who might be trying to tackle this, I would say, a very, very challenging but very, very important problem of robot safety.
Okay, one last question for you here. Looking ahead, what do you envision as the next big breakthrough in robotics that will fundamentally change the way intelligent robots are developed and deployed in the real world? And how will tools like AirSim continue to shape that future?
Yes, Daniel. So I do know that the future is the following. You go to your favorite store, either online or physically, and get a robot. And this robot gets connected onto the cloud to a robot AI service. And as soon as it's connected to the cloud, it basically the intelligence is propagate to the robot. It's almost as if, the robot can see the world. It can understand the physics around it. It knows what are the environments it's going to operate in. And, pretty much it's ready out of the box to accomplish some of these difficult missions that we're trying to code. Right now the model is that we will bring the robot and then we will write our code and this complex software that goes on onto it, and they'll accomplish some things. But moving forward, general purpose robot intelligence will be available for anyone to plug their robot into it and utilize all this latest and greatest work that many folks in the AI community, in the computer vision community, in many different engineering disciplines are doing, and it's available to be used by your own robot. Tools such as AirSim, such as some of the new work that we are doing at Scale Foundations, would enable you to first evaluate these technologies and then deploy and manage them at scale. So again, in a nutshell, it's robot intelligence available to every single device that's operating in the world.
Very exciting. Again, we are joined today by Ashish Kapoor, CEO and co-founder of Scaled Foundations. Ashish, would you like to share where our listeners can learn more, see the full blog, or reach you at?
Absolutely. So, if our readers, if I recommend our readers to go and check out at scaledfoundations.ai. So that's HTTPS scalefoundations.ai. We have a tool called Open Grid that's free for anyone to use. So you can sign it up right now and start looking at robot intelligence, including simulations and AI models, and start building all these technologies into your robot and for free.
Great. Well, thank you again for joining us on the podcast today. And thank you to our listeners for tuning in. If you or your company is interested in recording a podcast, please reach out to UAS Magazine. And for more podcasts like this one, visit uasmagazine.com and subscribe for industry news. We hope that you enjoyed this podcast and look forward to next time. Thank you.